In this video, we're going to continue our notes in section 1.6 on the second derivative by looking at example 2. So just recall in the previous example, we summarized some of our findings between derivatives and the shape of curves. In particular, we looked at some new notation, and that was concave up and concave down, new vocabulary rather. And these words are meant to describe graphs based on the sign of their second derivative. So visually, we can tell the difference between a concave up graph or a concave down graph, but not always. Sometimes it's rather difficult to determine if a graph is concave up or down based on just looks. So in order to confirm that it is concave up or down, we need to consider or compute the sign of the second derivatives. So that's what we're going to do in this next example. So example 2 says, for each function f, decide whether the graph is concave up or down and give reasons for your answers. So just visually, we can see that this first graph looks like an upside down bowl. So it would be concave down. This graph on the right looks like an right side up bowl, so it would be concave up. But we want to provide reasons for our answers. So in order for a graph to be concave down, what would that mean about its second derivative? Second derivative would have to be negative. In order for a graph to be concave up, its second derivative would have to be positive. So let's justify that that is in fact the case. So we want to show that the second derivative of x is less than 0 here. So recall the second derivative just describes how the first derivative changes. It's the change of the first derivative. So to consider how this first derivative changes, let's first draw in some tangent lines to allow us to visually see what the tangent line or what the first derivative is doing. If we draw in some tangent lines here, we can use a little thicker pen. We want to consider the slopes of those tangent lines. So what's happening to these slopes as we move left to right? So if I look at this line first, 1, 2, 3, just keeping track of the ordering that our tangent lines were in. So as we see, as we move left to right, our tangent line looks pretty steep at first. And it gets a little less steep, hits 0. And then it starts to get steeper, but more negative. So our tangent lines, the slopes gets more negative. So the tangent line slopes continue to decrease. So again, here it starts pretty steep, gets smaller slope till 0, then continues to decrease its slope as it gets more negative. So to summarize our findings, we could say the tangent line slopes, or the slopes of the tangent lines, the slopes of our tangent lines decrease as we move left to right. So that first derivative is decreasing. Because recall, the slopes of the tangent lines are the first derivative values. So if our first derivative is decreasing, that would mean the change of our tangent lines is negative. In other words, the second derivative of x is less than 0, which is what we wanted to show. And I just want to repeat that again. So our tangent lines, the slopes get smaller. So those slopes decrease. So our derivative decreases. So then the change or the difference from one tangent line to the next is going to be negative. The difference of those slopes as we go left to right is going to be negative. It's going to start some amount and then it's going to change to be smaller. So that difference is going to be negative, which is why that second derivative is negative. So now let's look at the second graph. Change up our color here. So we want to show that the second derivative in this example is positive. So to do that, in order to show that it's concave up. So to do that, again, I'm going to draw tangent lines on our curve from left to right. And I want us to observe what happens with the slopes of our tangent lines. Here's our first one, second, third, fourth, fifth, sixth. So our tangent line starts out pretty steep and negative, then gets less negative. The slope gets less negative until we hit 0. Then our slopes start to increase in the positive direction. So then we can summarize here. The slopes of our tangent lines increase. Again, starts out very negative, gets a little less negative, hits 0, then gets positive and even more positive. So that would mean our change f prime of x increases. The slopes start really negative and then increase to positive. So our changes increase. So that would mean our second derivative is positive. So to summarize, we proved or showed that our first graph was concave down by showing the second derivative was negative. And we showed that our second graph is concave up by showing our second derivative is positive there.